All right, so our goal today is to understand a little bit about normal distribution and standard deviation. That's our goal by the end of the day. Those are kind of new words, so it'll be good. Okay, data can be spread out many different ways. There is left skewed, and you can tell because the tail is on the left. There is right skewed. And then there's that mess. This one's bimodal, by the way. The other two are unimodal. You can tell they're bimodal because there are two with the same peak. Okay, but there are many cases where the data is not skewed, no bias left or right. This is called a bell curve. This is also known as the normal distribution. Okay? All right. So symmetric means the mode, mean, and median are all about in the same place. When it is left skewed, the mean is skewed a little to the left. And the mode is always in the middle. The median's always in the middle, and the mode's always where the most occurring thing is happening. Okay? Right skewed is the exact opposite. It's going to pull your mean to the right instead of to the left. Okay? All right, let's take a look at this, and let's decide what kind of distribution, the different kind of dice rolls we can get with 2 dice. So we can roll 2 ones, and then we can roll a 1 and a 2, or a 2 and a 1, so getting a 3. We can also roll a 1 and a 3. Or we can roll a 2 and a 2. Or a 3 and a 1. Notice we don't count the 2s twice because it's a 2 on both dice. Yes. Okay, we can also roll a 4 and a 1. Or a 2 and a 3. Or a 3 and a 2. Or a 1 and a 4. So there's the dice roll so far. These are all the ones that add up to 2. These are all the ones that add up to 3, all the ones that add up to 4, all the ones that add up to 5. So let's find all the ones that add up to 6. So this would be a 1 and 5. A 2 and 4. A 3 and a 3. A 4 and a 2. And a 5 and a 1. Leaving our last one. How lovely. So this is a 1 and a 6, because these are all the ones that add to 7. Then this would be a 6 and a 1. And this would be a 2 and a 5. And then a 5 and a 2. Struggling there. Then we've got a 3 and a 4. And finally, a 4 and a 3. Okay, so those are all my possible dice rolls for the first half of my data. So if you go ahead and make all the final rolls, can you finish the rest? And what is the shape of all possible rolls? So we could go back down the other way. So this was 7. So what are all the possible rolls that add up to 8, 9, 10, 11, and 12? So if we look at it in its entirety, we can see that this is a normal distribution. Because the peak is in the middle, the mean, median, and mode is in the middle. It's all 7. Okay? Now, let's talk about 2 different concepts. So population is the entire population. So if you were able to that would be an entire population sample. If you had a sample, it is a part of the population. So that'd be like one person out of every major city in America or something like that. Or every city. That'd be a lot. It's a lot of people. Okay. So we're trying to decide, are these samples or populations? So you ask 38 ninth graders in the hallway what their favorite sport is. So if you only ask 38 ninth graders, is that all the ninth graders? No. So this would be a sample of all of ninth grade. So if we collected a data from all the third period classes for those who are wearing blue shoes that day, then that would be a population sample because it's going to be every student in the school that showed up to third period. Right? Okay, I want you to read this and decide, is it a sample or a population?